So we are in Unit 7. This is Learning Objective 2, which is to identify the factors that determine the rate at which a solute dissolves in both a solid and a gas. So identify factors that determine the rate at which a solute dissolves. So this is both a solid solute and a gaseous solute. You do have two different parts of a solution. So your two different parts of a solution are solute and solvent. The solute is the thing that is being dissolved, the substance that's being dissolved, whereas the solvent is the substance that the solute is being dissolved in. So when we talk about the rate at which something dissolves, or rate in general, what we are talking about is how fast, so the speed. So when we are talking about rate, we're talking about the speed or how fast something happens. So again, there are two different parts of a solution, which we need to cover first before we actually start talking about this. So two parts of a solution. The first part is the solute. This is the substance that's being dissolved. And then you have the solvent, which is the substance the solute is dissolved in. Water is your universal solvent. So most of the time your solvent is water. The only time that it's not water is if the substance doesn't dissolve in water. So if it doesn't dissolve, then we would think about a different solvent. So solids would be considered the main type of solute that we would have. So ways to get more of a solid to dissolve. So a couple of ways that you can take and get a solute to dissolve. So you need to know the ways at which a solute can be dissolved faster in a solution. And then you also need to know why. Okay, so number one, we'll talk about like one, and then we'll talk about why. Okay. So your first thing to get more solid to dissolve in a solution is stirring the solution. Now, why is this? Why does stirring a solution cause more of the solute to dissolve? If we're stirring, we're increasing the kinetic energy. So remember kinetic energy from the last unit. All right, so if we're stirring, we're increasing the kinetic energy, which means that we're increasing the surface contact. Now, dissolving anything is a surface phenomenon. It happens at the surface of a solid. So what that means is that the part of the solid that is coming in contact with the solvent is what is being dissolved. The inside of the solid is not actually being dissolved until you can get the solvent to that point. Anytime that you want to increase the rate of dissolving something, you're wanting to increase the surface contact between the solute and the solvent. Anytime we increase that surface contact between the solute and the solvent, that's going to increase our rate at which the solid is going to dissolve. Again, the rate is how fast. So stirring increases the kinetic energy, which increases the surface contact between the solute and the solvent. Your second way to get more solid to dissolve is increasing our temperature. So think about it. Like if you've got cold tea versus hot tea, it's easier to dissolve sugar in hot tea than it is cold tea. Part of the reason for that is because of the increase in temperature. If we decrease the temperature, okay, then you might have some of the sugar come out of the solution. It happens, okay? So if you ever go to like Dunkin' Donuts or something like that and get an iced coffee, sometimes they have that sugar at the bottom of the iced coffee. That's because it was dissolved in a hot solution, and then the sugar just kind of precipitated out of the solution. Okay. So why does increasing the temperature increase the rate at which a solid dissolves? Well, number one, heating a solution is going to increase your kinetic energy. Remember, temperature is related to kinetic energy. So heating solution causes an increase in kinetic energy, okay? Which means that we have more particle movement, which again is causing that increase in your surface contact between the solute and the solvent, which causes you to increase your rate at which your solid's going to dissolve. Now, an important thing to remember here, really important thing to remember. And anytime that you want to get something to dissolve in like water or something else, dissolving a solute, you must have intermolecular forces between the solute and the solvent. Dissolution, dissolving, only occurs on the surface of the solute. So if the solute cannot get to that surface, then you're not going to dissolve your solid. If there's no intermolecular force between your solute and solvent, then again, you are not going to dissolve the solution into the solution. Okay, so dissolving a solute, you must have intermolecular forces between the solute and the solvent. So they have to have similar intermolecular forces. If they don't have similar intermolecular forces, then you're not going to dissolve that solute into that solvent. Okay, so if I have, for instance, a nonpolar compound trying to dissolve it into a polar compound, okay, their intermolecular forces are different. A polar substance has hydrogen bonding, dipole-dipole interactions, depending on like what it is, okay, especially if it's water. Whereas a nonpolar is only going to have London dispersion force. Now, yes, your polar compounds do have London dispersion force, but that's not the force that's overpowering everything else. That's usually your dipole-dipole hydrogen bonding. So they have to have something that's similar between them in order to actually cause them to dissolve in one another. Our third way of getting a solid to dissolve into a solution is to grind the solid into smaller particles. So take a sugar cube versus powdered sugar. Powdered sugar is going to dissolve a lot faster than the sugar cube, especially if you're not doing anything to it. And again, so grinding your solid into smaller particles. So why is it that when we grind a solid down into smaller pieces, it causes it to dissolve faster? Well, the reason for this is that we are increasing our surface area of the solid. So remember, dissolving is a surface phenomenon. It happens on the surface of the solid that we're dissolving. So if we're increasing our surface area, that means that the solvent can get down into those little particles and pull them away. Okay. So this is increasing the surface area, which again, we're increasing that surface contact between the solute and the solvent. And because we increase that surface contact, that's going to cause an increase in the rate of the solid dissolving. Again, remember, rate is just that, how fast is it occurring? Okay, the faster it dissolves, the more surface contact you have. Okay, so now this is a little different. So gases are a little bit different, but we do mix gases into solution. So if you think about a carbonated beverage like Coca-Cola, Pepsi, Mountain Dew, whatever, soda or pop or whatever you want to call it. Okay. Carbonated beverages would be considered a gas dissolved in a liquid. If we're wanting to dissolve a gas into a solution, what are ways that we can get more of a gas to dissolve? Okay, so when we talk about ways to get more of a gas to dissolve, these are also the reasons why sodas go flat and also why they fizz when they're opened. One of the first ways that we can get more of a gas to dissolve is by lowering the temperature. So this is counterintuitive, okay? Whereas like your solid stuff was very intuitive, this is kind of counterintuitive. So, but we can lower the temperature. So why is it lowering the temperature causes more of a gas to dissolve? Well, this is the reason is, and you have to think about this in terms of gases. Gases have some of the highest kinetic energy. Again, when you increase your kinetic energy, they're moving a lot faster, so they're not going to stay in solution as easy. So if we decrease our kinetic energy, that's going to cause, and this is just of the gas particles, this is going to cause an increase in the gas liquid contact. So again, is this solute solvent contact? The more you have the solute solvent contact, the more you're going to have your solute dissolve in the solution. Okay, so we're increasing our gas to liquid contact, our solute to solvent contact, which is going to increase the amount of gas that's dissolved. Okay, so increasing that solute solvent contact, which is going to increase the amount of gas that's dissolved in the liquid. Okay, and as we decrease our temperature, we're becoming more of a real gas, which has intermolecular forces and all that type of thing. So the gas becomes more real, which means that it has more intermolecular forces to kind of keep it in that solution. All of this is why hot sodas go flat. So the reason that hot sodas go flat quicker than a cold soda is because you're increasing that kinetic energy of the particle, which causes the gas to come out of the solution a lot faster. So the second way to get more of a gas to dissolve in a liquid is to increase our pressure. Well, if we increase the pressure above the liquid or the solvent, this makes the gas come into more contact with the solvent, thus increasing our solubility of the gas. Now, again, like you're increasing that contact, and the more you increase that contact, the more you're going to get to dissolve. So increasing the pressure above the liquid or the solvent makes the gas or the solute come into more contact with the solvent, thus increasing the solubility of the gas. Now, this is known as Henry's law. And this is also the reason why when we open a soda, it fizzes. So when you open a soda, you are releasing some of the pressure that's over the top of the liquid, which causes the soda to fizz. Now, if you have a ton of pressure, like you've shaken the bottle up, yeah, it's going to come out. Like the liquid's also going to come out as the gas comes out because you've increased that kinetic energy again, which is going to cause it to come out. So again, this is learning objective 2, unit 7, learning objective 2, which was to identify factors that determine the rate or speed at which a solute dissolves.